What up, calculus students? We are combining the last two lessons. What did we learn 2 lessons ago? That slopes, we've already known this, but just really driving it home. That slopes tell us if things are increasing or decreasing. So slopes of f tell us if f are increasing or decreasing. And then last lesson, we said the slopes of the slopes will tell us how the slopes are increasing or decreasing, which in turn tells us about the function's concavity. Today, we are just combining those two things. So we will be able to determine what a function looks like just based on the signs of the first and the second derivative. For example, if f prime is positive and if f double prime is positive, I know my function is increasing concave up. Increasing concave up looks like that. If f prime is negative, f is decreasing. If f double prime is negative, f is concave down. I need somehow decreasing concave down. Decreasing concave down looks like that. F prime positive, f double prime negative. So I'm going to be increasing concave down. Go up, concave down. And then the trickiest one is going down, concave up, at least to me. So first derivative negative, f is going down. Second derivative positive, concave up. Going down, concave up. And then we've realized that we could be asked about if our function is increasing at an increasing rate or increasing at a decreasing rate or decreasing at a decreasing rate. And we really bring out this word rate. And first of all, we know that calc is the math of change. To find change, we need a slope. Cool. Well, a slope is a rate of change. So whenever you see the word rate, you should be thinking the slope. This is a very important thing. Whenever you see the word rate, you should be thinking about the slope. So we have f that's going down, and we have f's slopes that are going up. Well, if f's slopes are going up, f is concave up. So decreasing at an increasing rate is something that students don't get right ever. They think decreasing, but getting faster while we go down. You are wrong. This is not correct. If my rates are increasing, my function should be curving up. My slopes should be getting less negative going towards zero. This, everybody gets wrong in every calculus class ever. Decreasing at a decreasing rate. If f is going down and f's rates are going down, a lot of people think it's that. No, but decreasing at a decreasing rate is actually decreasing concave down, which actually looks like this. Cool? So whenever we see the word rates, what's best is actually to translate it, not to try to just think about it. Like rates that are positive. Okay, my rate is positive. Rates that are decreasing. Okay, my rates are decreasing. If my rates are positive and my rates are decreasing, I know my function is going up. Hey. And my function is curving down. Are you working on calc?
Yes.
All right, come on. Cool. So the rates are positive. The rates are decreasing. My function is going up, concave down. I look like this. My rates are positive. My rates are increasing. My function is going up. My function is concave up. Okay, so it's two separate things that we need to look at. All right, cool. Didn't have these on your notes, but you should be able to figure out what is most likely true for the signs of f prime and f double prime. What's very important is the statement most likely. Is it guaranteed to be true? We can't say because we only have a select amount of points. However, if we can see we're going from 1 to 3 to 7, we can look at the rates of change. We can look at really the average rates of change and see this is a +2 and a +4. Well, that means my first derivative is positive. My rates of change are positive. And my rates of change are increasing. That means my second derivative has to also be positive. Cool. So like my first derivative is positive, my function is increasing. Okay, you could say my function's increasing. My function is curving upward because my rates are going up. Or the slopes of the slope are positive. You can actually look at the slopes of the slopes if you want to and see that they're positive. This is probably what I would consider the easiest way to do it, is just to look at the slopes and what the slopes are doing. You could also attempt to graph this and see that we are increasing concave up, and then know that increasing means the first derivative is positive, concave up, the second derivative is positive. But, I think this is a little bit more reliable. So if I go from 7 to 3 to 1, my slopes are negative, but the slopes of my slopes are positive. Or my slopes are negative, my function is decreasing, that's cool. My slopes are increasing in their values from -4 to -1. That is an increase of values, which means my second derivative is positive, which means my original function is concave up. So my answer is that my first derivative is negative and my second derivative is positive. 2 to 5 to 4. Okay, 2 to 5 to 4. F prime is going to change signs. It's going to go from positives to negatives. So I can't say it's positive the entire time. I can say that the slopes of my slopes are going to be negative. I can say that F prime is decreasing from +3 to -1. So my second derivative is negative. So I would probably just focus on my second derivative being negative for this one and not really talk about the signs of my first derivative. I can see that my slopes are 2 and my slopes of my slopes are 0, or they're consistent. Or my first derivative is positive, my function's increasing, but my second derivative is 0 because I don't have any concavity. So that'd be an answer here. I go -2, -3. My slopes are negative. So my function is decreasing, 1 to -1 to -4. But the slopes of my slopes are also negative. I'm concave down. My slope values are decreasing from -2 to -3. So my second derivative is negative. If you look at that. 5 to 5 to 5. My slopes are 0. My slopes of my slopes are 0. So that's most likely true. Now, again, this is most likely true. Can we guarantee that in between these points, we're going to have other 5s? No, we might go up, down, and come back up and get to these points 5. So most likely does not mean guaranteed. Cool. Let me pause. You got it? Cool. So when is F increasing concave down? When F is decreasing at a decreasing rate? The way to answer this question is to do 2 separate sign analyses and to combine them. So we got to do our first derivative sign analysis. We got to see when it's equal to 0. We got to see when it's positive and negative. Throw it down. You got to get fast at doing your first derivative analysis. And you got to do a second derivative analysis, which we do by looking at the second derivative and setting it equal to 0, and you get x equals 2. And if you wanted to factor, you could. We plop these on top of each other. We do the sign analysis of everything, and we know about the signs of our derivatives. We know about the derivative increasing and decreasing. We know about the curvature. When is F increasing and concave down? What's very important is to line these things up. Get them aligned so that you're looking at your intervals when we are anding, not oring. F is increasing when F prime is positive. F is concave down when F double prime is negative, when F prime is decreasing. I'm going to go from -infinity to 0. That's when we are both. That's the only time they overlap. Let's do another one. When is F decreasing? Here's F decreasing. When is the rates decreasing? The rates are decreasing when F prime is going down. Okay, that's when F prime is going down. 0 to 2 would be my answer to that question. Okay. Great. Next. And this is really what we talked about in class as our curve sketching questions. We don't really get asked in calculus anymore to sketch a curve. It used to be something that we did all the time in calculus. And if you ever retake calculus and you go to college, you will be asked to like do even more to provide an accurate sketch of a function. But you all won't need to do that because you're going to pass the AP calculus exam. The second derivative is 18 minus 18x. Second derivative equals 0 at 1. F double prime. If I plugged in 2, I'd get negatives. If I plugged in 0, I'd get positives, which means my first derivative is increasing and decreasing. Which means my function is curving upward and curving down. All right. Align things. Cool. F is decreasing, concave up. F is decreasing, F is concave up. All right, when do they align? Negative infinity to 0 again. F is increasing at an increasing rate. So F is going up and its rates are going up 0 to 1. Okay. Let's go. If you want to skip one of these, that's fine. Like if you feel like you got a handle on things and these are repetitive, great. This is the example of just like, we're just practicing. We are making sure you understand how to do it. And if you do, great. If you don't, then you need to practice. Negative, positive, negative. We will change signs. If I look at a second derivative, 60x squared minus 20x cubed, and I factor out a 20x squared, I'll get 3 minus x. I get a 0, but I'm going to get a 0 at 0 and a 0 at 3. So it's nice to make sure we align things. I'm not going to change signs at 0 because of the square. That factor will always be positive. So it's only the x minus 3 factor, or the 3 minus x factor, that could change. If I plug in 4 negatives, change signs, don't change signs. All right, so now I know how f is changing, increasing or decreasing. I know how f prime is changing, increasing or decreasing. I know the curvature of f. When is f increasing, concave up? Here's f increasing, here's f concave up. So 0 to 3 is when we overlap. When are f's rates negative? So f's rates negative, f's rates decreasing. I'm looking for f's rates negative, f's rates decreasing to infinity. Cool. Cool. I get plus or minus 1 and 0. You could factor this to x plus 1, x minus 1. So we got 0, we got negative 1, we got positive 1. Not going to change sign at 0. It will change signs at positive 1 and negative 1. So that's telling me how f is changing, increasing, decreasing, decreasing, increasing. We got maxes, we got mins. We have a critical point that is neither a max nor min. Okay. I'm going to factor out a 2x, and I get 2x squared minus 1, which actually gets me a plus or minus a half, root half. So I should be considering 0, positive root 1 over 2, and negative root 1 over 2. Those values are definitely in between 0 and negative 1. I can see I'm probably going to change signs, but I could check, plug in a positive, 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 great. I can see the square, but if I plugged in something very, 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 very small and subtract 1, it'll be negative. Something very, very small and positive will be positive. So I can see I'm going to change signs here. And I can see I change signs here. If I plug in something very, very small and negative, square it times 2. Yo, get in here. Yo, shout out Xander from AP Calculus last year.
Y'all
We got Conrad this year. You in it?
Am I in the
Carson got a 5 on the AP Calculus exam last year. He crushed. He knows. Xander, did you get a 5? Xander got a 4, but that's okay. That's all right. Xander should have gotten a 5. F prime, decreasing, increasing, decreasing. F concave up, concave down. All right. F's rates are positive and decreasing. So the rates are positive. The rates are decreasing. So I got negative infinity to negative 1. F is decreasing at a decreasing rate. So F is decreasing. F's rates are decreasing. Cool. So decreasing at a decreasing rate would just be 0 to root a half. Okay. So F's is decreasing. F's rates are decreasing. If you have all of your analysis done, you don't have to translate it much. You could just answer the question. Okay, brings us to the next set of questions, which is preparing you for your test. Heads up, this is stuff that you're going to see on your test. The idea of most likely versus always true. Okay? The question is, which of these statements must be true of f of x? And you're going to see this f of x, but what you need to understand is that just because you think that you understand the slopes, just because you think you understand the shape of things, does not necessarily mean that things have to be true. For example, is f prime positive on the interval from 1 to 3? Well, you're like, oh yeah, f prime is positive on the interval from 1 to 3. But does it have to always be true? No. This is why this is a most likely. However, this is not a true statement because I could put a value at 1.5 that is negative 4. And all of a sudden I'm going from 110 to 1.5 negative 4, which means my derivative is negative in that interval. So not always true, we would say this is not true. It's most likely true, it's not always true. Just because you have a set of points makes always trues tough. Is the second derivative negative? Oh yeah, well it looks like my slopes are decreasing. It looks like the second derivative from plus 5 to plus 2 is minus 3. And you'd be like, yeah, well, don't say it's definitely true. Because again, I could just plug another point in. And all of a sudden, it's not always true. So we say this is false. Is the derivative at 3 equal to 0? Well, maybe. Most likely. It makes sense if this was the location of the max. I'm not even going to say most likely. I'm going to say maybe. But what if I put a 0.3.5, 19? And maybe we don't have a 0 there. Maybe we keep increasing and then we start decreasing. So this is not always true. Is the second derivative positive from 3 to 5? Oh yeah, it looks like the second derivative is positive, but we can put one extra point and that's not going to be true. So not always true. Most likely true, not always true. The derivative has to equal 0 somewhere between 1 and 5. Yes. As long as this function is differentiable and it's smooth, which I should say that this function is differentiable. Why do I know yes? Why do I know this must be true? Well, you can just think about the function. It does go from increasing to decreasing. F will increase and will have to decrease eventually, which means the signs of f prime must go from positives to negatives, which means we must cross through a zero. This is definitely true. So there's only one of these statements that has to be true. Another way to do this is to look at the mean value theorem. Do you remember the mean value theorem? It's going to be on your test. That's about A rock equaling I rock. We'll look at the average rate of change from 1 to 5. From 1 to 5, the change in the y is 0. The change in the x is 4. So on average, the function is increasing 0 y's per x from 1 to 5, which means there must be a derivative that equals 0. So, cool. All right, this is just a different type of question. This showed up on the AP pre-calculus exam, where they are giving you the rates of change of f. So you are told about f's slopes. F slopes are positive, then negative, then positive, then negative. F's slopes are increasing, increasing, decreasing, decreasing. Remember, F's slopes increasing, decreasing, second derivative positive, negative, F curving up, curving down. F slopes positive, negative, F up, down. You got to really have these two sign analysis down. So when does F have a relative extrema? That's when F goes up and down or vice versa. So F will go up and down. Here we'll have a x equals 2 max because f prime is positive from 1 to 2, then negative from 2 to 3, and then positive from 3 to 4, and then negative from 4 to 5. So f is going to go up, down, up, down. So x equals 2 is a max, x equals 3 is a min, x equals 4 is a max. When does f have a point of inflection? When f's slopes change direction. So that's going to be at x equals 3. Again, you could do the second derivative sign analysis, which tells you about the first derivative. We are increasing, increasing, decreasing, decreasing. We are focusing on 3. So we have positives, negatives, curvature, curvature. When is f increasing, concave down? So f is increasing here and here. F is concave down here, so it's 3 to 4. Decreasing at a decreasing rate, so f is going down and f's slopes are going down, which means f is concave down. Or we could just look at f prime being negative and decreasing. F prime is negative and decreasing 4 to 5. Great. Can we get to some graph questions? Great. When is f increasing, concave down? Well, f is increasing when f prime is positive. F is concave down when f prime is going down, or when the slopes of f prime are negative, f double prime is negative. Since this is the graph of f prime, I should be looking at the signs and the direction. F prime should be positive and decreasing. The answer is 0 to 2. When is f decreasing at a decreasing rate? So f is decreasing, f prime is negative. F's rates are decreasing, f double prime is negative, or f is concave down. Well, since this is the graph of f prime, I should be looking at when it's negative and decreasing. Negative and decreasing would be from 2 to infinity. See how this works? You got to find the correct characteristics, double the characteristics. F is decreasing when f prime is negative. F is concave up when f prime is going up, and when f double prime is positive. When f is decreasing, f prime is negative. F prime is negative and going up. When are you negative and going up? Just here from 2 to 3. When are f's rates positive? F's rates are positive. All right, well, I already have f prime, so I just need to look at it. When are f's rates decrease? Okay, I mean, it's really telling me what to look at. When is f prime positive and going down? Positive and going down would be here and here. So negative infinity to negative 2, and from 0 to 1. Critical points. X equals -2, x equals 1, and x equals 3. Why? A critical point is when the derivative equals 0. Cool. How many extrema? Well, that's when f prime changes sign. That's when f's going to change direction. So x equals 1 is our max. X equals 3 is our min. We do not change sign at -2. -2 is a critical point. That is not an extrema. How many points of inflection will we have? Well, points of inflection are going to occur when f prime changes direction. That's when f double prime changes sign, or f changes concavity. So changes direction is at -2, 0, and 2. Cool. How many critical points do we have? Critical points are when their derivative 0 or undefined. I got -3, -1, and 2, or 1. So 3. How many extrema? Well, that's when our f prime is going to change signs. We change signs here and here. So we'd say x equals -3 is the location of a max. X equals -1 is the location of a min. X equals 1 is a critical point that is not an extrema. How many points of inflection do we have? That's when f prime will change direction, which is when f double prime changes sign. F prime changes direction at -2, 0, and 1. When is f increasing concave down? F is increasing when f prime is positive. F is concave down when f prime is going down, or when f prime slopes are negative. F prime positive and decreasing. Positive and decreasing, positive and decreasing. -infinity to -2, or is that -3? -3, and from 0 to 1. All right, f increasing, f prime positive, f concave up, f prime going up, f double prime positive. Since this is f prime, look at when it's positive and increasing. Positive and increasing here, positive and increasing here. That's it. -3 to -2 and 1 to 2. Where's f decreasing concave up? F is decreasing when f prime is negative. F is concave up when f prime is going up. F double prime is positive. Since this is f prime, negative and increasing. So negative and increasing will be here and here if we look from left to right. Make sure you're looking from left to right. Make sure you're looking from left to right. Where is f decreasing at a decreasing rate? So f's slopes are negative and f's slopes are decreasing. So negative and decreasing will be here to here and here to here. So -1 to 0 and 3 to infinity. Cool. What if I give you the graph of f with a point of inflection at 1? Remember, this is the graph of f. When is f prime greater than 0? Okay, that's when f prime is positive. That's when f is going up. When is f double prime positive? F double prime being positive means f prime is going up, means f is concave up. Since this is the graph of f, I should be looking at when it's going up and concave up. I can see we're concave up and concave down. We are going up and concave up from 0 to 1. Whereas f decreasing at an increasing rate. So f needs to be going down and f's rates are going up, which means f is concave up. So going down concave up would be this portion when the graph of f is going down and concave up. So -infinity to 0. Let's look at 2. Well, I can see that f of 2 is positive because it's like a y value. I can see the slope of f at 2 is 0 because I can see it's like a horizontal tangent. And I know that the second derivative is going to be negative because f is concave down. If f is concave down, the second derivative is negative. So I'm going to say f double prime is less than f prime is less than f. Cool. Again, skip some problems if you feel like it's repetitive. But if you haven't done it yet, do it, I will go through this. For those of you who need the practice, try it yourself. If you're just copying this down, what are you doing? Thanks. All right, so F is going down, concave down based on the signs, going down, concave. So the points of inflection are at -2 and 0. You're told that here. So going down, concave down would be here, just 0 to -1 to 0. F is going down. F's rates are going down, which means F is concave down. That's the same question. Same exact question. Let's look at -4. 1, 2, 3, 4. I can see that the function value is 0. I can see that the first derivative is negative. And I can see that the concavity of F is concave up, which means the second derivative has to be positive. So now I'm going to go F prime is less than F, which is less than F double. Points of inflection at -1 and 1. When is F going down, concave up is the translation of that. Here's going down, concave up. Concave down, concave up, concave down. So -1 to 0 again. Cool. When are F's rates positive and decreasing? So when is the rate positive? That means F is going up. When are the rates decreasing? That means the second derivative is negative. That means F is concave down. So when are the rates positive and, oh wait, when is F going up, concave down? Going up, concave down, I would say is here. Going up, concave down is also here. So I'd say -infinity to -2, and I'd say 1 to 2. Let's look at 0. F of 0 is negative because the y value is negative because this is F. F's slope is 0 because we see a horizontal tangent. And because I see that the function is concave up, I know that the second derivative is going to be positive. So I have F is less than F prime is less than F double prime. All right, that was fun. Wonder how long that was. We'll find out. Peace.